GraphQL caching demystified. So, Matteo, take it away.
Oh, cool guy, cool Cody, just straight in, amazing. I'm sorry, guys. I'm sorry, folks, for
We're
this.
just getting started.
For this voice, I am. Fortunately, I got a little bit of a cold, which has been plaguing me for the last few days. I don't know. I have a small kid, so you know how things are. Anyway, let's get things started. Okay, so I have my slides ready to go, and I have. And I'm ready to talk about GraphQL caching and kick off Untangling GraphQL. So, and here we go. Share my screen. Yes. Okay. Hi, folks. So, hey, you got my screen. Amazing. So, who I am and why I'm here, I don't know. I'm Matteo Collina at Matteo Collina on Twitter. Please follow me if you can. If you don't, it's the same. But I really like when people follow me on Twitter, follow me back on Twitter. So some lights is very useful. So cool. Cool. What are we talking about today? I'm a magician. Okay, I'm a kid of the 80s, and I was extremely fascinated by when they did this show of David Copperfield in TV, where the man was cut in half. And look, it's really nice because in order to be able to pull on some magic trick like this, it requires so much work behind the scene to make sure that everything works exactly how you think it should. And yeah, I really like to say that I'm a magician. I make things disappear and make things fast, and they look like it's they're just there. So it's easy. Okay, when in reality it's actually not. Okay, so what are we going to do today? So today I'm going to show you how to improve the performance of your GraphQL gateway by 4 times. What? Really? Can we make GraphQL run 4 times faster? Is that even possible to begin with? We'll see. I don't know. I don't know. Cool. So, what are we going to use? Some tools of the craft. So, first of all, I have we're going to use Fastify. What's Fastify? It's a I don't know. I wrote it. Okay, so it's together with Thomas. So it's a fantastic framework that you can use. It's an awesome framework that you can use to build web applications on top of Node.js. It's really fast, as says the name. It has very low overhead, but it also offers a really good developer experience with embedded logging, validations, and all the other features like that. So, and but we're talking about GraphQL. So what's GraphQL? Well, GraphQL is based on Mercurius, which is the GraphQL adapter for Fastify. Again, it's really fast. Whoa. Okay, how fast is it? Well, it's fast. You can see the difference with a few other alternatives out there. So it also offers gateway mode, and it also supports federation as a target, to be integrated with. It's great. We're also going to use AutoCannon, which is a load testing library that I wrote a long time ago. So it's time for doing some magic and some experiment. Okay, so first of all, let's consider a gateway. What's our gateway? Well, our gateway is a Fastify app running Mercurius with the gateway mode targeting 2 services. One that serves users and the other one that serves post. We are also enabling just-in-time compiler. What is just-in-time compiler? Basically, it takes your GraphQL query and it converts it and compiles it into a very, very fast to execute JavaScript function. Whoa. Okay. Those target services actually serves data from memory. this is one of those target services. So we have our queries, we have our type users, and we can specify the resolve reference and those things. Okay. Common, right? Should not be anything specific. Okay, so it's time for some magic now. So let's try something. Okay, so but before doing magic, we need to set our baseline. We are performance engineers, so we need to set how is our services running without doing anything. Okay, without doing magic at all. Well, we have 3,000 requests per second with a latency at the 99th percentile of 80 milliseconds. Is it good? Is it bad? It just is. We just want to optimize this. Okay. Then what we can do is we can generate a flame graph out of that system. Okay. And if we do that, the Mercurius gateway is already pretty fast. In fact, as you can see, when you're doing a flame graph, and a flame graph is a visualization of where your application is spending a lot of its CPU time, you will see that spending most of the time in Undici. What's Undici? Undici is the next generation HTTP library for Node.js. It's really fast. It's actually way better than HTTP.request. Was written from scratch, and as you can see, uses a lot of WebAssembly in it. Hey, that's great, right? So a lot of the time, most of the time here is actually spent there. We're actually spending a lot of the time just doing HTTP requests. Well, it's a gateway, right? So if it's a gateway, you're actually spending time to do HTTP requests because it's a gateway. If it wasn't a gateway, we wouldn't spend time. So how can we optimize this? We're spending time doing HTTP requests. How can we optimize this stuff? I will show you how we'll make that disappear. So how much can we improve this? Well, just by enabling the caching with no time to live, so we are not caching anything at all. Okay, we can actually just improve it 4 times. We can actually improve our latency down to 18 milliseconds. We can improve our number of requests per second, the median to 13,000, and we could actually improve the throughput 4x too. Whoa! How did we do that? Like 4x? Ow! Well, you can even do better, slightly better, right? Because we can actually improve a little bit, because we can actually increase add a little bit more time to live, and things gets better still. So we can do 4 times, okay? And look, if we do it, we can now generate a flame graph, and we see that the HTTP requests completely disappear. How it's even possible? Look, it disappeared. Okay. Well, we are doing caching now. So here we go. That's where we are doing the caching bits. How does it work? Where did the HTTP request go? Well, let's see. The technique that we have been using is called deduplication. Nobody likes clones, right? So we just slay the clones. That's it. Okay. So a lot of you have definitely seen this diagram about the event loop. How does Node work? Well, Node.js scheduled runs some JavaScript which schedule asynchronous I/O activity either on the kernel async I/O barrier or on the thread pool. When those have completed, they put in events into the event queue, and then Node.js pluck things off from that event queue and run and execute all of them. That's a very high level. The diagram that we are probably not very familiar to is this one, which is exactly the same as before, but with a different focus. So we are just zooming in on the specific part when we are receiving an event and there is an event to be processed. When an event arrives and needs to be processed, the first thing that happens is that it executes some C++. Node.js executes some C++, and that it's going into executing a JavaScript function. That JavaScript functions in turn typically schedule some promises. That's what it does. And then those promises are all executed, are all resolved. Okay. Seems about right. How does this matter? Well, it matters because when we receive an event, when you call an async function, okay, the result of an asynchronous function, it's a promise. So if you could compute a key for that execution, okay, you could actually dedupe that. You could actually put, you can actually store the key with all the an hashing key, okay, for that, and based on all the arguments, and then we could retain the promise in a map. Then when the next call arrives, okay, then a follow-up call that wants to execute the same JavaScript function with the same arguments, you could actually fetch the promise, okay? Instead of going and actually fetching the things from the database, you could essentially just, oh, well, I'm already fetching the data from the database for this other user, for this other call, so maybe I can just wait for them and completely avoid the call. So this is called a dedupe cache. So, however, writing this stuff, it's really hard, so don't do it yourself at home. However, there's a nice module that we wrote that is actually very easy to use, which is it's called it's the cache module. It's a sync cache dedupe. You can just create it and you can specify your TTL if you want. You can define your operations, okay, and then you call. There is a little bit more to it, and there is a lot of that in the APIs and checking the README, but it's great. So we can actually dedupe all the things, okay? It's really powerful. However, we were at the point where we needed to compute a good cache key. Like, given the async function, in order to be able to dedupe the calls to dedupe the call to a database, we need to actually make sure that we are computing using a good cache key. Well, reality is that we can actually do that very easily because we have our root. So because actually every JavaScript, every GraphQL resolver, it's actually an asynchronous function. So what we can take the root object, we can take the object, we can take the arguments, we have the content, which is the Node.js request, response, database, and so on and so forth, and the information about the query. So we can actually take all that info and use that to compose a cache key. However, in order to do so, we need to create, a string because a cache key is a string. So, well, we could take all the arguments and just use JSON stringify. However, if we do so, it's the order of the arguments changes the order of the positional order inside the object changes the string that's being generated by JSON stringify. However, there's this cool library called Safe Stable Stringify that actually solved the problem. So check it out. Note that this is actually the main bottleneck of our application. So if you want a better algorithm, go for it. So apart from that, how are we computing the cache key for GraphQL? Well, a little bit more complex than that, but we need to also take into account the fields and a few other things. However, TLDR, it's we are actually computing a JSON, a stable JSON stringify of some stuff. So as I said, just using this dedupe logic, it can actually improve your performance by 4 times. Pretty incredible. Basically, we're just shedding load. So we can't just keep the load up. We can just, well, we're just not doing the work. It's nice, right? And then we have 1 second TTL. Okay. However, all of this was caching data in process, right? But, doing that does not really work because it gets out of sync between multiple processes. So we can't have a higher TTLs, time to live. And it's very easy to stop into memory leak. So, well, the solution, what is the solution of everybody? Just use Redis, right? Everybody just said, just use Redis. Throw Redis at it. Turns out it did not work. Why it did not work? Well, let's consider that you have 100 GraphQL queries, each of them invoking 20 resolvers for each of your servers. So this means that you will have essentially 2,000 Redis get per second. if you want to verify if a cache entry has been added for them in Redis. However, Redis uses Redis protocol. It's actually request response, so it's blocking. So you can't do that because you need the time it takes to respond for send the messages for this to respond. Needs to be 0.5 milliseconds. So to be able to do that doesn't really, that's not the case, because on our measurement the P99 to sending a comment to Redis is 15 milliseconds. So it doesn't compute. How can we do that? Well, I solved that problem already. So cool. Okay, so you can check it out. Basically, it's that problem is called head of line blocking, and it's, I will call it a solved problem. You can just use the IORedis library and Autopipelining that automatically batches the things. How does it work? So imagine that inside your application, you want to send, all those 2,000 comments to Redis that we were talking about before. Well, a technique to be able to remove that big round trip time is to use this concept of pipelines. So Redis pipeline. So basically, it takes instead of sending them all one by one, it batches them in a pipeline and then send the pipeline to the client, to the server to execute. Autopipelining essentially batches all the commands that you have been sending inside the pipeline, and it sends all of them immediately after the first one, as soon as the connection is free again. In this way, you can actually cut the round trip time immensely. So it's, the numbers are phenomenal. Well, these look a lot like the previous technique, though. In fact, it is. It's actually the exact same technique that we were doing before. It's actually turtles all the way down. Some real life statistics about this system. We have put it in production for one of our clients, and we have seen 100 times more throughput on a real world server. Basically, it's great. Okay, the numbers are phenomenal. Okay. And then this does a 15 times expansion on Redis. So basically, it executes a huge load of Redis commands for this complex graph. However, there are, as we all say, two hard things in computer science, and one is cache invalidations. Okay, and the other one is naming things. Cool. So we need to talk about cache invalidations now. So, well, how can we implement cache invalidation in this kind of a system? Well, we do have them. Okay, so we have what we called tagged cache invalidations. So it's really cool. How do they work? Well, first of all, they support Redis, of course. Basically, whenever you fetch a data from a resolver, you can specify which tag you are using. Okay, so you can specify what are the reference for that. As you can see on the right in the example, we can see that the top post references as a tag of top posts, but the single post can have a tag that includes the ID of the post. Cool. So how does it do with these tags? Well, whenever you issue a mutation on the system, you can actually automatically invalidate all the tags that are relevant. And then basically you can say that when you are when you want to update a post, you could actually invalidate both the posts and the get post for that specific one. All of this system it's really cool because it's stable on Redis, so it's not leaking a massive amount of memory. However, it's going to execute. It's going to have a few different duplicate copies of the same content while it's running, because it needs a lot of indexes to be able to do this operation fast. Those will eventually expire if the system does not receive any load. However, you might want to run a script that keep it clean, on which is called the garbage collector script. Run it every hour or so or something, so that it can it helps you keep your database size small. And well, we are done, and we are done. So a little bit about me. I'm chief software architect at NearForm. I am part of the Node.js technical steering committee. So created a bunch of open source. So hey, here I am. And yeah, if you want to learn more about the stuff, you can follow my newsletter, Adventures in Nodeland. I typically write about my releases and updates to my software. So cool, folks. Little bit about NearForm before we finish. It's NearForm is a professional services company. We are based in Ireland. However, we are in 29 countries so far, so we are really remote. Okay, there is an HQ in Ireland, but I don't know. I think only a few people are there. Hi, NearForm HQ. I think we have people going on a very soon. Some of our employees will go on a trip to visit the HQ. You know, they've been working for the company for 1 year and they never been there. Anyway, a lot of good stuff happened in that building. Anyway, yeah. So we are hiring. So if you want to work in professional services and do amazing technologies like GraphQL, Node.js, React, whatever, really, check us out and feel free to reach me out on Twitter if you have any questions. And thank you, folks.
Awesome, Matteo. That's great. Thank you for all that. So we got a couple of questions that I was thinking about. If you're still here, I'm wondering about the throughput and like how can it be improved by doing caching with 0 time to life? Like what's the magic with the throughput and the 0 time to life?
So the fundamental bit is that we are not doing the work. So you are by doing the deduplication, we are completely avoiding doing other calls. So basically, we can essentially, as I always say, it's be careful with what you do. We are basically crossing the streams, like in Ghostbuster fame, okay, and making completely avoiding some of the work, or basically untapping raw power of the proto stuff that the Ghostbuster were using. So I don't know.
I love the Ghostbusters metaphors that bring me back to my childhood. So what happens when two queries...
it's the kids of the 80s, as I said. Whatever.
Yeah, me too, right? So what happens when two queries select different fields?
So this is a very interesting bit. So the cache key, as you can see, includes the fields. So basically, you will have 2 entries in the cache.
Okay.
So unfortunately, that's what it is. Okay. So it's we can't avoid it. Okay. Well, potentially we could, but it's actually hard. So
yeah,
we are not doing it now.
Maybe some future. Yeah, exactly. So I don't know if people in the audience know or not, but you and I both work at NearForm, and I'm lucky enough that we can both work together. And I know, Matteo, that you have some conferences coming up. Do you want to tell anybody?
Oh yeah, sure. There is a few bits that I want to promote. There is OpenJS World coming up in a couple of months. I think it's together to the GraphQL conference too. So you should really come to Austin at the beginning of June. So it's really cool. It'll be a fantastic event. So let me check. Okay, so is there America? I don't know. Okay, I don't know. I don't have a clue. But there's going to be quite a lot of activity and buzz about the OpenJS World Conference, which is going on at the beginning of June. I will be there. I will be delivering the keynote. Hopefully it will go well. Finger crossed.
Of course. Yeah.
Amazing.
Any closing thoughts? I didn't
one more thing. We have NodeConf.
Yeah.
So NodeConf will go on. The ticket will go on sale as soon as we finish the website. So which it's an unclear date, but we have the date for the conference. So if you are cool into coming to Ireland, because we are doing it in person, and again next time. And if you're keen in coming to Ireland in Kilkenny, we are doing the conference from the 3rd to the 5th of October 2022. Oh, wow.
That's going to be great. I've actually been in NodeConf twice before I worked at NearForm, and I know it's an amazing conference. So yeah, come. It's going to be so much fun. Awesome, Matteo. Thank you so much. Looking forward to the next conference and learning a little bit more about GraphQL.
Perfect. Bye. Bye-bye.
Bye, Matteo. Thanks.